So we have spent all this time doing, I don't know what just happened. Hopefully it's still recording. Doing two pieces that equal the combined total. But now for all of these pieces, I'm going to have more than three pieces of information. So if you look, the top line is broken into three segments, but I don't have a total for that segment. And I'm asking you to find this piece over here. So remember that as we solve math, as we're in class, we're trying to figure out how to use what we're given and how to solve the problem. So sometimes you'll get home from dinner or try to make dinner and you're like, well, I don't have what I wanted to make enchiladas and I don't have what I wanted to make chicken. So what do I have and what can I make with what's there? What kind of combination can I come up with? So when we look at this, this is the piece that I want to find. But it's not related to anything else that I'm given. It is kind of related to this, but those are all variables, so that's not helpful. But what I can see is that AB plus BC equals AC, because AC is this line right here. So now I can substitute. It doesn't get me what I'm looking for yet, but maybe it gets me there. So AB is 5 plus x, and BC is 2x, and together that equals 11. Now that's not getting us where we want to be yet, but all the problems that you're given, especially at this level in high school, have a solution. There's enough information in the problem to get you to the answer. It just might take a little bit of a detour. So then we combine like terms. How many x's do I have? Total. No, this is how much right here. This one is 1. So then 1x plus 2x is 3x. So that's 5 plus 3x equals 11. And then we subtract 5. 3x is 6. And then we divide and get x is 2. But remember, what I'm looking for is CD, and that's 5x minus 1. So when I substitute, because now I know that x is 2, that's 5 times 2 minus 1, 10 minus 1, which is 9. So at first, I didn't need that 5x minus 1. It was just extra information. I needed it at the end, but not to start the problem. And so you want to make sure that as you're solving these, that you're figuring out what you can use, how it works together, and when I tell you that every problem that I give you has a method to solve it, that I've given you the tools to solve it, so that you don't look at it and go, well, I don't know enough. Because there are times when you get to higher math that you don't have enough information to solve the problem, but not in this class. So you might need a hint, but you have enough information to solve it. Everybody ready for the next one? Nope. I don't want to cut it off too soon. All right. Good? Okay. No? Seriously? Go ahead. You're good? What the? I don't want to go too fast. Mara's like, I was almost there. Yeah? Okay. So, same thing. How can I use what's there to get where I want to go? So what I want to know, AC is this piece right here. But I don't know how to get that. I can't, I'm missing this piece right here to be able to use those three pieces. And if I use these, I'm still missing that piece. So what do I know? I know that AD is the whole thing. And I can say that AC and CD, that equals the whole line, right? So I can say this is AC plus CD. And then I can look at it and say, okay, and then I can say, well, this piece, 10, that I know, this is 10 right here, and this piece, that also equals AD. So I can say that AD equals AB plus BC. Remember that if you want a colored pen or highlighters so that you can mark your pages so it makes sense, they're back there on in one of the buckets on the shelves. So that still isn't enough to be done, except that I noticed that they're both equal to the same thing. So if they equal the same thing, that means these two are also equal. So I can say AC plus CD equals AB plus BC. And then I have all of those pieces that I can substitute into my formula. So AC is 2x plus 7, and CD is 11, and that equals 10 plus 3x plus 2. So we combine like terms. 2x plus 18 equals 12 plus 3x. I need to move the variable to the left side. That's negative x plus 18 equals 12. So then minus 18, so I have negative x equals negative 6. But I can't stop there because x can't be negative. So how do I get rid of that negative? Technically, that's an invisible 1, right? So then I need to divide by negative 1 to make that into a positive 1. So then I get x is 6. But then I need to remember that I'm looking for AC, which is right here. 2x plus 7. That's 2 times 6 plus 7. 12 plus 7 is 19. It's a little bit more complex. You have to really look at the picture to find the parts that are related. That's why it's a 4. But if I were to give you a problem like this and you could begin to set it up, then I would see some of the other skills, levels 1, 2, and 3, in the problem. Because you understand that these two pieces equal the whole thing. This is what we've been talking about this whole time, is that this piece and this piece together equal the whole thing. It's the segment addition that we're working on. All right. Now comes the tricky part. If we go from here to Castle Dome, and then we go from Castle Dome to Circle K, do you see that some of that is overlap? Like we went the same part of the same way twice. We went there and back twice. There is overlap in this picture. These three pieces right here all cover the same distance on the number segment or line segment. So if we go and come back and go, like that's too many times to count that. So how can I fix it? So let's start by looking at the whole thing is dt, right? And the two pieces that I have are df plus at. But then I need to get rid of this piece. So then I'm going to subtract AF because it overlaps right here, right? So if I can just take that part away, then I have this much, and that's my whole thing. So then we just need to substitute. So dt is 15. df is 3x plus 2. at is 2x plus 3. So there's a plus in there, and minus 5. And then we combine like terms. But you wouldn't know to do that if you couldn't set up the equation, because even though it ends up that we're subtracting 5, you wouldn't know that that's all you needed to subtract from both pieces. So we combine like terms. 3x and 2x is 5x. And then plus 2 plus 3, that's plus 5. And then minus 5 is 0. So then that's all we have left. Those cancel. So we divide by 5. And x is 3. Now that's not what I asked you to find though. So df is 3x plus 2. So that's 3 times 3 plus 2. 9 plus 2 is 11. So when they overlap, you're trying to figure out what you can subtract so you don't count that part twice. Because again, this looks like I went here, and then I went here, and then I go back. So I only need to have 2 of those. So if I do this, then it only has this one piece. If I can subtract it, then it cancels one of them out. Okay, got one more. Okay, so this is the same thing. The two pieces that I'm given overlap. So I can't say that this plus this equals 22 because there's an overlap. So how much do I have to subtract? X minus 1. So when I write this, I'm looking to say, okay, so dk, that's the whole thing, because I know what that is. That equals dc plus uk but then I have to subtract out UC because they overlap. If I did it as DUC and UCK, can you see where they overlap? Can you see that both of them have this? And so that's the part I need to delete. So when I substitute back in, DK is 22, DC is 14, UK is 2x minus 1. Here's the tricky part. UC is 2 terms. So I need to put it in parentheses so I can remember to subtract both, because minus a minus becomes a positive. So when I distribute my invisible 1, 22 equals 14 plus 2x minus 1 minus x plus 1. So when we combine like terms, 14 minus 1 is 13, plus 1 is 14 again. And then 2x minus x is plus x. And then we subtract 14, and I get x is 8. Yeah. And so now I'm going to take that back up here because UC equals x minus 1. Now I know that x is 8 minus 1, so UC is 7. So maybe if when you're writing it, you write this little piece right here where you can see what the crossover is, then that'll help you see what you need to subtract. Because I only need to have it once. And right now, according to that top line, I have it twice. So I just need to get rid of one of them so we only cross that distance one time. Okay?